Assalamu alaikum. So from now onwards, we are going to be beginning the statistics and probability syllabus of Cambridge A-levels. Okay. Now, if you want, you can skip this video. The reason being, in this video, I am just going to talk about the basic probability, right? Nothing advanced. And honestly, what I'm going to talk about in this video is not even, it's just a prerequisite, right? Whatever I'm going to be mentioning in this video, most of it is going to be from, what you should already know from O levels, right? Just so that you can refresh your mind, right? So this is not going to be the advanced probability, rather just the prerequisites, or rather, if I should put it this way, the basics, right? Let's just enough with the yapping. Let's just finally start with it, right? So S1, obviously, never mind. Hey, give me a sec. It's been a while since the last time I've used this. Okay, so this is how you erase stuff. Done. Now look, S1. Okay, or A2 if you want to put it that way. Now look, the thing with now look, what actually is probability? Probability is just chances, right? Whenever you've got a chance for something, if you want to be able to represent the chance for something, for anything that happens, right? You represent it using probability. That is just the simplest way I can put it forth, right? Now, when I say something happens, anything that happens is an event, right? It's an event. So this is a word that you're going to be using over and over and over again in the entirety of, the component of statistics. That is event, right? So anything that happens is an event. That's simple, right? And obviously, you know what? If something has not yet happened, then we can, obviously there are only two outcomes. An event or something that can happen, it can happen or it might not happen. I know I'm just shooting bullets in the air, right? You might not exactly understand what I'm trying to say. As of now, don't mind my battery though. As of now, you might not exactly understand what I'm trying to say, but the moment I start writing stuff down, I hope it's just going to start making more sense, right? So, um, an event takes place, right? So an event might take place and it might not take place, right? Just either of the two things can happen, right? In order to represent the chance of something happening, we use probability. That's it, right? Now let me give you how do we use probability, right? Now, look, let's just forget probability for a second. I hope most of you might have already played Minecraft, right? I'm going to make Steve just my best drawing of a Minecraft character, right? And these are his legs, right? I've been playing Minecraft Dungeons a lot these days. Never mind. So you open your Minecraft inventory, right? Let's say I don't exactly remember how many boxes there are, right? But let's say, you know what? I think I made a big one. Let's say this is your Minecraft inventory for an example, as an example, right? Now, if you just look, how many boxes in total are there? Six, right? If I say that two of these boxes are occupied, then how would I write it as a fractional number? Just look at it this way. If I've got total six boxes on my Minecraft inventory and I've got to represent it using a fractional number, how would I do it? I would say, let's say, out of the six boxes, only one of them is occupied, right? This one is occupied. How would I represent it? I would write 1 over 6. This is the fraction that I'm going to use, or the fractional representation of how many boxes are occupied, right? And how many boxes are unoccupied? I can write 5 over 6. It's literally this simple. If you understand this, I don't really think you're going to have much problem with statistics or with probability, your entire next 2 years or a year or so, right? This is the case with probability. The formula for probability, now I would rather speak in the more mathematical terms, right? The mathematical or the professional, the formal terminology for this would be favorable outcomes divided by the total outcomes, right? That's it. Literally this. And obviously this tells you that the denominator, this thing, the denominator, right? I'm just going to write D because I'm lazy, is always going to be greater or bigger than the favorable outcomes, right? Because obviously the favorable outcomes is something that you take from the total outcomes. It's a subset, it's a small thing apart taken from the total outcomes. Obviously it has to be lesser than that. I just hope I'm trying to make myself clear. Those were some very silly examples I gave, right? So now that honestly is probability and there's nothing more to it. But yeah, there are quite a few things to it, but the basic simple thing about probability is this. Okay? Now look, let's take an actual example. Let's say I've got myself a dice, right? I've got myself a dice. 4, 3, 5. This more like looks like a cheese block or something. So it's a six-sided fair dice, right? A six-sided fair dice. Now, in case if you're going to throw it, now what's an event? If I say, tell me the probability that, six appears on the top face of the side if I'm going to roll it, that is an event, right? Like the dice lands on, let's say, 5 or 4 or 3, right? That is an event, right? Dice is rolled, it lands on 5, right? I have to tell you the probability of this event. So this is the event that the dice is being rolled and it's going to land on a specific number, and that number in this case is 5, right? That's the thing. Now, how would I represent the probability of this event occurring? Right? How would I represent the probability for this? This is how I'm going to do it. You see, probability of this event would be, um, no, look, how many, no, look, every time you're trying to find the probability of something, this must be your thought process. Okay, this is important. This is significant. Remember this. Every time you're trying to find the probability for an event, what do? You try to look at all of the possible outcomes and then you look at the outcomes that you are searching for, right? So for example, in this case, it would be, what are the total outcomes? You can either get a 1 or a 2 or a 3 or a 4 or a 5 or a 6, right? These are your total outcomes. These are all of the possible outcomes. You cannot have a 7 or an 8, depends upon what kind of a dice do you have. But in this case, it's only going to be these 6, right? And now what outcomes do you need for the event, for the probability, right? What are the outcomes or the possibilities that you are searching for? That is 5, right? You're just looking for 5 to appear, okay? You're just looking for 5 to appear. So these are the total outcomes, and this is the favorable outcome, okay? This is the outcome you actually need. How are you going to represent it as a fraction? Use the formula. In total, just never mind. Just count them. 1, 2, 3, 4, 5, 6, right? You've got 6 total outcomes. So that would be 1 over 6. I was about to write 5 over 6, which was actually a mistake. Why? Because I'm not asking you to write the numbers directly. I'm asking you to count the outcomes, right? I can literally write, never mind. I can literally write what A, B, C, D, E, F, G. I can literally write it that way, right? Because the numbers don't matter. What actually matters is the number of the total outcomes. And the total outcomes in this case are 6. Let's say the dice didn't have, let's say the dice didn't have these numbers. It instead had 5, um, 5, 10, 11, 12, 13, or 20. 1, 2, 3, 4, 5, 6, right? Now these are six numbers as well. I'm asking you to tell me the total number of outcomes in here, right? That is 6. So these are the total number of outcomes, and the favorable outcome is 5, right? Now in case 5 didn't exist, let's say 5 didn't exist in here. It was, let's say, 21, right? In that case, the probability would be 0. Why? Because there are no favorable outcomes, right? There just are no favorable outcomes. Why? Because we need a 5 and the 5 just doesn't exist. So your total probability would be 0, right? Another thing about probability is that, as you can see, probabilities are always represented as simple fractions, right? Simple fractions. And obviously a fraction, well, look, that tells you, look, I'm sorry, never mind. Probabilities are always represented as fractions, and the fractions are such that the denominator is always going to be greater than the numerator, right? That is one thing which makes sense. This tells you one thing about probability, and that is a probability for an event, for any event, is always going to be or equal to greater than 0 or equal to 0, and it's going to be less than or equal to 1, right? That is one thing. Another one thing that you are going to find very, like very useful sometimes in an exam situation is that, let's say you find, now look, for the same event, we might say, if I wanted to find the probability for a 20, let's say, for a 20, right? In that case, what would I write? What would be the probability? The probability would be 1 over 6. Why? Because the total outcomes are 6 and you've got just 120 in there. If there were, let's say, two 20s, you would write 2 here. Why? Because there are two favorable outcomes now. But right now we only have one, right? So this 1 over 6 is the probability of the dice landing on 20, right? What if the examiner in the next part of the question asks you, what would be the probability that the dice would not land on a 20, let's say, right? And honestly, let's just not do a 20. Let's just write them all over here again. 1, 2, 3, 4, 5, 6. Let's just not go with random numbers. Let's just be simple, right? So let's say that the probability for the dice landing on a 1 is 1 over 6, right? Why? Because there's only one. If had there been two ones, I would have written 2, right? I would have written 2. Let's say there are two ones, so my probability for the dice landing on a 1 would be 2 over 6, right? So that's one thing. Now, what if the examiner asks you, what is the probability that the dice is not going to land on a 2? Sorry, it's not going to land on a 1, right? So it's kind of like the complement. So now look, the event here is, the probability of which we are going to find is, the event is, the dice can land on literally any number other than 1, right? So the total outcomes remain the same, right? But the numerator, the favorable outcomes would be 4. You know why? Because you're just going to exclude the two ones over here, right? And these are the only ones that we're going to count, right? So if you get or if the dice lands on a 3 or a 4 or a 5 or a 6, the event is still being satisfied, right? The event is still being satisfied. So you are going to have yourself a 4 over 6. Another way you could have done it would have been, if you have, let's say, the probability of an event, right? And then the examiner asks you the opposite of that event. For example, in this case, this is the probability that the dice would land on a 1. You wrote 2 over 6, right? Now it asks you whether what would be the probability for an event where the dice lands on a number which is not 1, right? Any number other than 1. So we already have the probability for an event, and now the examiner is asking us to calculate what? The opposite of that very event, then all you have to do is just minus the probability of the main event from 1, right? That would be 2 over 6. And this again gives you 4 over 6. You get the same answer, right? So if you've got like too many, or let's say you're short on time in the exam, and you didn't have quite a lot of time left on the clock's ticking away at your time, right? In that case, you don't have to manually calculate the complement of an event. If you have the probability of the main event, right, then you can easily calculate the probability of the other of the complement of the event by just subtracting it from a 1, right? Why? Because the total probability is 1, right? So if you take away the main probability, then all you're left with is going to be the probability for that event not occurring. That's what I'm trying to say. Okay. These were 2 points we discussed, right? Just a simple recap. What is probability? It is, the chances of an event taking place, right? We took a look at it, and we looked at an example of representing fractional numbers using the Minecraft inventory example, right? Then we learned about the formula for probability. And yeah, obviously, if this is D, then this has to be N, right? Never mind. Just have to write it over there. Then we looked at the example of an event of a real exam situation, you throwing a dice, and how you're going to calculate the probability, how you're going to count the favorable outcomes and then the total outcomes, and then you've got yourself. And then we learned about this point, right? The total probability is always going to be greater than 0 and lesser than 1, or and obviously 0 and 1 are inclusive, right? Then we learned if you have, and look, let's learn about notation, right? How do you write it? Let's say an event is, that's literally the last thing, right? I'm not going to vary you guys, I'm not going to tire you guys, I'm not going to exhaust any of you with this Herculean effort of learning probability. We're just going to end the lesson right away now. Okay, let's say that an event is dice lands on 4, right? You can simply name this entire event, you can name it A. This event is called A. So the probability for A is going to be 1 over 6. Okay? That is how it works. This is the notation. This is just how we write it. So probability of event A. We could have written probability brackets dice lands on 4, but that is, informal kind of thing, and that's just not cool, right? That just makes you look like a moron. Sorry for that. Language. I know. I'm sorry. So this is just how you do it. If you want to find the probability of the opposite of this very event, you would write it P complement, right? And P complement is the dice lands on any number but 4. Like it's not going to land on 4, but it can land on any other number, right? In that case, you're just going to be like 1 minus P8. This is how you're going to write it. The mathematical way is this. That would be 1 minus 1 over 6, and that would be 5 over 6. So this is the last thing we learned, right? And yep, I think that's enough for today. Inshallah ta'ala, from tomorrow onwards, we are going to be looking at the actual probability stuff. I mean, it's still going to be basic, but we are finally going to transition into the A levels kind of part of probability rather than just the O level or the basic things of it. Okay, so I think that's it from my side. We'll see you, inshallah ta'ala, in the next video.